questions? Questions? All right, well, I'll ask a little later again. So, just a quick look at the schedule. So we have class today, class on the 28th. No, well, whatever. No class on the 1st because I'm at a conference, and there's an exam on the 3rd. I already put out a practice exam, so go and have a look at the practice exam so you know what format these exams are like. So during the exam, you use your laptop. You will be getting the exam text over the internet. You submit it to Canvas. Otherwise, do not use the internet for anything. No Google, no email, no communication with any carbon life form. So be sure to put everything onto your computer before. You can use anything that you have on your computer before you enter the room. So it seems like a good idea to, for example, download all the solutions from all the homeworks. That way you have them available if you need it. And in fact, it's not just a good idea to download them, it's an even better idea to look at them, because I wrote the exam and every one of the questions has something to do with a homework assignment. So even if you've not succeeded in a particular assignment, it's well worth your time looking through all of them and understanding the answers, because those are the starting points for all of the exam questions. It's also a good idea to have the book code available, just in case that there's a snippet of code that might be useful for that. So put that on your laptop as well. You can bring the physical book, or if you happen to have an e-book, you could bring the e-book. I guess if you only have the online version, I have to amend it to say it's okay to read that. The network may or may not actually work. As you know, it's sometimes flaky, and it's flakier if it's important that it works. So I would imagine on the exam you might have some issues. So be sure to bring a USB stick as well. That way, if push comes to shove, you can get a copy of the exam on the USB stick. And conversely, you can use the USB stick and plug it into my or the proctor's computer to submit your answers in case the internet fails. Also, bring an extension cord. All right, there's like 2 power outlets in this room. That's obviously not really going to be enough for everyone. But if like everyone brings an extension cord, then one can daisy chain them up here, the hallways. And as long as the fire marshal doesn't see it, that's just fine. All right, so work through the practice exam. I purposefully did not give answers to the practice exam because I know that those who need the practice most would be just too tempted to look at the answers. So work through that. If you have any questions about it, put those questions on Piazza. It was an actual exam that was given last semester or the semester before, so it really is a pretty fair reflection of what might be on this exam. Any questions about the exam at all?
Looking at the practice exam.
Yeah.
And number 5, it says to
Let me.
include the date. For the date, is it?
Let me look. Yeah. Hang on. Let me look at that. I think I know what you mean, but I want to be sure. Practice exam is here. Right. All right, so we want to print out the date in every letter. So which instance field should be added to the mail class? This is in 4C. Let me have a quick look at the solution of 4C. So now I put all the solutions at one spot. It was silly to whatever I did before. So let's see. 4C. Yeah. Just by the way, when you look at these here, solution is the draft and solution 2 is the final. And you'll also see the rubrics in here that were used to grade your thing. So right now we have instance variables for the before and after text and the sender. And then you should put one that can hold this thing here. And the easiest way to do it would be to just add another string.
Okay, so it's not like we're not going to use the Gregorian calendar to automatically.
No, that's not what was intended to do this. But if you wanted to, you could say a string or a Gregorian calendar would be a valid answer. You wouldn't lose points for that answer. Or you could even say that day class that we had from one of the worked examples or whatever it was. That would be fine too. But a string was what I'm sure whoever wrote this question intended. Yeah, those are good questions that you guys should ponder. Other questions? Do you have a class on Friday? We never have a class on Friday.
We have a lecture.
Oh. You mean there is no 28th? That was a typo? We don't have a class on Friday, so let me. If I messed that up, that would be bad. Where are we? So 28th is a Friday? Oh no, that's wrong. That is wrong. All right, I'll fix that. However, no, however. Okay, never mind. There's no class on Friday for sure, and you don't need to know this material for the exam. I had a quiz that was due on October 1st. I'll still have to. Okay, I'll ponder that. Send me an email or a Piazza question about this, and I'll fix it. There was a question whether I needed this for the exam, because if you notice, this exam here, the practice exam, requires a little bit of knowledge about if-else. There's a few questions that use if-else, and I'll have to double check whether for the exam that I just wrote that's also true, in which case I would make you read through this before the exam. But it's only if it is required at all, it's only the most basic part of it. All right, so let's go on. Today's lecture. So, there's not much that we want to say about basic numbers. We know the distinction between integers and floating point numbers already. We've seen the notation for floating point numbers where you use the e if you have very large or very small numbers. The most important part for us is overflow. So if we look at this little code segment here, and let me actually demonstrate this real quick. So if over here I say int n equals, this I believe is 1 million. Here it is. And now if I compute n times n, then you notice that something very strange happens, that 1 million squared is not 10 to the 12, but it is minus 7 something. How could it get negative? Yeah, so the integers must be stored in a total of 32 bits, and so this needs more bits to be represented, and then it just gets randomly rounded, not randomly, but it gets rounded modulo those 32 bits, and you can just get a negative number as a result. So, and notice there's no error message or anything, yeah? No. What it is it's just the last 32 bits of 10 to the 12, but since the top bit is the sign bit, it just happens that that one is set, so it's negative. So there's a 50% chance that any overflowing number is negative, because that sign bit, you know, could either be 0 or 1. And I just picked this example to be dramatic looking where it just is negative. Notice there's no error message, and so this can silently happen, and it is occasionally a problem. When this happens, the basic remedy is to switch to doubles. So if I were to say double x equals 1,000 times 1,000, and then I compute x times x, then that is 10 to the 12, and all is fine. So anytime that you're in the situation that you need more digits than fit in 32 bits, you know, try switching to double. There's another type that you can use, the long type. I don't think we'll ever do that in this class, but you could. That gives you 64 bits. So int and double are really the staple of what we need. Now, on the other hand, with floating point numbers, with doubles, you get other issues that are also somewhat unpleasant. So, for example, here, I'll set double f equals, what is it, 435. And now let's look at 100 times f. And notice that it is 434 point something. And that actually looks pretty strange, right? Here you have a number that uses 2 digits, and then you multiply it by 100. So surely that should be 435. I mean, how hard can this be? But you get 434.99 something. So you get a slight round-off error. And the reason for that is that in the binary system that's used in the computer, there's no exact representation for 4.35. So just like in the decimal number system, you can't exactly write 1/3 as 0.333, and there would be an infinite number of 3's. To do 4.35 in binary, you need some infinite repeating pattern of 0s and 1s, and it gets truncated somewhere. So you get these tiny errors when you use them. And there's totally nothing you can do about it. It's a fact of life, and you simply have to realize that when you make any floating point computations, these small round-off errors can happen. Now you might say, how do I ever write banking software? Because your customers are not going to be amused if there are these issues. And there's 2 ways around it. The first one, and that's the one that we're going to be using in this course, is to rig it so that people don't see the mistake, and you can do that by using system.out.printf, and we'll talk more about that in the next lecture, but I'll just show you right now. So I can say I want 2 decimals, and I want to show 100 times f. And then it prints it with only 2 decimals, and now it looks accurate. It actually isn't accurate. You just can't see the inaccuracy because we're saying show it with only 2 decimals. And then it takes, you know, the 999 and says, oh, that's actually 435.00. So that's a common remedy that we'll be doing whenever we need to print that. Actual banking software works a little different, yeah?
I was just curious, are there a lot of these non-whole numbers in decimal?
What's that?
Are there a lot of these kinds of numbers?
Oh, yes. You should expect that in general, when you use doubles for computations, that you will get small round-off errors. More often than not, you'll get a round-off error. And even for like innocuous-looking numbers, like 4.35. So there'll be plenty of example programs that use like cash registers, and it'll happen. If you just try them out, you just add some reasonable numbers of dollars and cents. It's very likely that the sum of them will be off by just a little bit. And so the easiest way to deal with it is not to show all of the digits, because the round-off error happens so far toward the end that if you round to 2 digits, you won't see it.
If you use float values, that'd be float type.
Oh yeah, there is a float type, and which I have on this chart here. And so there's one thing to remember about float, and that is don't ever use it. There was a time 30 years ago when memory was so precious that it made sense for some applications to use float. I can't. The only time that I've used float is because some fool library forced me into it. I can't imagine that you would ever run into this. If you have some computation that uses an incredible a data set of numbers and you need to store them all in memory, then float might make sense. But that data set has to be truly humongous for you to want to do that.
But let's say, for example, we're forced to use float. Do we still use printf, or do we use?
You still use printf, but no one's going to force you to use float.
But double uses more digits, or uses more digits than float.
Yes, that's the point. So double uses twice the number of digits as float. And so float is so imprecise.
It's supposed to be like a memory saving function.
Yeah, float was there at the time when memory was far, far more expensive than it is now. And it's just kind of sad that float has the nice name. So sometimes you'll find textbooks that, that rightly so say the name double is so unintuitive that they use float anyway. But it'll get you in all sorts of other trouble. Use double. Other questions? All right. Now, in Java, unlike in some languages, you can't convert from a floating point number like here, the 13.75, to integer simply by making an assignment. So if you were to make this assignment here, hoping to just get the dollar value and truncate away the fractional part, that doesn't work by itself. Instead, we'll see later what you have to do. So, all right, let's have a clicker question just for fun. All right, let's have a look at these things here. So let's start with number 3 and see if this one is true or false. So we say India and China each have both about 1.2 billion inhabitants. And can an int hold 1.2 billion, yes or no? In fact, it can. It can hold a little bit more than 2 billion. So 3 is definitely wrong. Now, 1 sounds tempting, right? That, of course, you can't have fractional number of people. And so if, in fact, int is good enough for our needs, that would be a good answer to choose. 2 doesn't sound, I mean, it's true, but by itself it doesn't sound like a good enough reason. But maybe, I mean, it's more accurate. It's better to use int. So, so the real question is, can we get away with using int in this situation? And the answer is, it depends. It depends on what the program wants to do. If the program just wants to read and display those numbers, then you can get away with using int, because every one of those individual countries, one can use an int. If you wanted to sort the data set, say, so that the most populous countries show up on top, int would be good enough. But if you wanted to compute, say, an average, then int might get you in trouble, because how do you compute an average? You first have to compute the total, and as it happens, the total of the world population, it's more like between 4 and 5 billion, that gets you past the 2 billion. And so there's no one right answer to this question. It really depends on what you want to do with the data. If all you want to do is look at individual countries, you could choose 1 or 2, and you can feel smug. If on the other hand you say, well, surely one wanted to compute an average, then 4 would have been a better answer. So there is no one right answer, and so there's only one really wrong answer that sadly was picked by 37% of the people. Oh, now it's 36%. What happened? So ponder that. All right. So once in a while I'll toss in a question like that that has no right answer. Constants. So this is an important subject. Whenever in your computation you use some number, such as in the sample program we use 0.25, 0.1, 0.05, and so on, you're supposed to be using named constants for this. So instead of writing quarters times 0.25 plus dimes times 0.1, you should use these named values. And so the rule of thumb is that anytime you use a number other than 0, 1, or -1, you should really turn it into a named constant. So you should come up with a name for it, and then you use this final syntax. They're called final for obscure reasons. Just think of final meaning constant. So you put the type, and then you put the name of the constant. It's customary, but not required, but it's customary to have constants in all uppercase. That way they're easily distinguished from variables. And then in all uppercase, you can't do the camel case trick, so that's when you have these little underscores here. And then you put the name of the value of it at the end. So this is just for making the program easier to read, for making it easier to change. Now, admittedly, it's unlikely that a quarter will ever mean anything else but 25 cents. But there are many situations when you use a constant where you do want to change it. For example, in the homework assignment number was 5A, where let me show you the assignment. Notice this transformation here. These values, the 20 and the 200, where do they come from? I mean, they're just values that I came up with because they seem to be doing a good job. And so in a situation like this, you definitely want to give them some kind of a name. So in your program, you will want to say like x times scale factor or some such thing. Plus plus offset. And that way, if I change my mind and I find that I want to scale it by, say, 30, then I can just change scale factor to 30, and I don't have to look at all of the 20s in my program and ask myself whether I should change those or not. So make sure that every time that you have one of these constants that you change it. If one leaves a number like this in a program, the grader will say, don't use magic numbers. So a magic number is a number that it's not entirely clear what it is that just appears in a program. And so the way to eliminate magic numbers is to use constants. Sometimes one has a constant that needs to be shared amongst multiple methods in a class. And in that way, in that case, the syntax is a little bit odd. You have to then declare them not as final inside a method, but as public static final, and you put them where you would normally put the instance variables. And otherwise, the declaration is the same. When you have one of those, then one can even use it outside the class by using the name of the class followed by the name of the method. The most common of those constants that you will likely be using is the number pi, which is available as math.pi. Now with math.pi, there's another powerful reason to use math.pi, and that is that if you didn't do it, it would be an awfully long number to type out by hand, right? Now I've seen some people, when they use pi, they always write 3.14, and that's of course a terrible habit because you're going to get round-off errors very quickly with that. So you want to use it as precisely as you can, and math.pi is definitely easier than typing that long thing. And it makes your program's intention very clear. So here I have a program, this cash register program, where you can see this in action. So up here I have a bunch of constants that are defined up here. By defining them up here, I can use them anywhere. Let's see if I actually take advantage of that. I really don't. In this particular program, the constants are only needed inside this method here. And so I could have equally well declared them just inside this method. All right, so I don't want to go through the cash register. Okay, now I just kind of gave away the answer for this. Yeah, I did. Oh well. So I can't use it. So what's wrong with this statement sequence? So that 3.14 is not an accurate representation. Well, should you use 3.14159 instead? No, right? And you could use 3.14159 and all those other digits that we had here, but that's still not optimal. You should use a named constant, right? Oh, is the circumference actually pi r squared? No, that's the area, right? Okay. So the correct answer would be 2. All right. Arithmetic operators. Generally, there's no big surprise here. We've already used multiplication many times, and you've kind of gotten used to the fact that it doesn't look like the multiplication that one normally uses in algebra. That's just because on the keyboard they don't have a symbol with a raised dot or a cross. Division is done by a slash. And so the only thing that you then really notice is that something that looks nice and compact in a mathematical notation, it starts getting kind of spread out when you write it out this way. Parentheses work in the normal way. So just like in regular algebra, multiplication and division bind stronger than addition. If you don't like that, you have to use parentheses. I don't think anyone's ever had difficulties with that. So. No, it does not recognize braces or brackets. So if you, if you wanted to have multiple levels of grouping, you would just need lots of parentheses. And so that's actually something that students sometimes dislike. So you might have A plus B minus C times D plus E, and then you have to close it with a bunch of round parentheses. Now, when you do that, in NetBeans, you'll notice that NetBeans actually matches them up. I'm not really sure what BlueJ does. Let me try this real quick. Does it match them up? Okay, let me just really quickly make a new class. So, yes, it does. So notice that when I typed the closing parenthesis, it highlighted the matching opening parenthesis. And so if you have more complicated expressions, that is really incredibly useful. And it's a common mistake to mess up the parentheses. And in fact, do I have this? Okay, that's too bad. I'll have to show you this trick in here. So if you have a complicated expression such as the one that you see, and you want to see whether the parentheses are balanced, typically what happens is the compiler says that you made some kind of mistake. And if you want to know where that mistake is, the following trick works. And you look, whenever you see an opening parenthesis, you increment a mental counter. So here I would say 1, 2, and then when you see a closing parenthesis, then you decrement it. So here it would be 1, and here you would say 0, and here you would say 1, and here you would say 0, and that's something that one can mentally do. So I would go through here and say 1, 2, 1, 0, 1, 0, and when you end up with a 0 at the end, that's good. But it's also important that nowhere in the middle did you ever get a negative number. If both of those conditions are true, 0 at the end and never a negative number, then the parentheses are balanced. Conversely, when you end up with, most commonly what happens is you forget a closing parenthesis and you end up with something that's not 0. So that's something that will definitely happen to you as the functions that you use are getting more and more complicated. All right. Increment and decrement. There's two operators that you'll be using all the time, plus plus and minus minus. Plus plus takes a variable, adds 1 to it, and moves the result back into the same variable. So if items contained the number 10 at one point, and then you say items plus plus, then afterwards items contains 11. And when you say items plus plus again, then it contains 12. You could say items equals items plus 1, but it's obvious why one likes to say plus plus. It's much less tedious to type. And it's a very, very common operation. People use it all the time. Integer division is a somewhat error-prone thing. So the slash operator has this curious nature. If at least one of the arguments, either on the left or on the right or both, if they're floating point numbers, then it works exactly like you would expect from your pocket calculator. It divides the two numbers. On the other hand, if both of them are integers, then it does something less happy. Then it says, well, they're both integers, so I want the result also to be an integer. I'm just going to throw away the remainder. And so 7 over 4, for example, it'll say that's 1. You know, we would expect it to be 1.75, but it's just going to say 1. So let me demonstrate that here in the code pad. It'll just say 1. And the remainder is completely lost. You don't see it. So if I do like 123 divided by 10, for example, I get 12, and not 12.3. The remainder is simply discarded. Now, if you want that, that's fine, but it's a common mistake that people forget about this fact. Now, you can get the remainder by using the percent operator, and so 7 is, when you divide it by 4, the 4 goes in once, and then you have this remainder of 3 that would give you the fractional point part, the 0.75. Similarly, 123 mod, as we pronounce it, mod 10, is also 3 because 120 is evenly divisible, and then you have the remainder of 3. So why would we ever want to have a remainder? instead of looking at this long example, let's do something simple. Let's say you have a value in pennies. So I have, in my piggy bank, I have 1,345 pennies. And now I may want to know how many dollars are that. And then I can divide by 100. And it'll say it's $13. So if you want the number of dollars out of the pennies, this is exactly the operation that you want. And now as you know it's $13, and you might want to know and how many pennies are left over, then you can use the modulus, and that gives you only the pennies, discarding all the dollars. That is a very common operation to fill out dollars and cents out of a total that's computed in pennies. And so the advantage of using pennies is, of course, you don't have round-off errors because it's all done as integers. So it's a common thing that you just compute everything in pennies. Integers don't have round-off errors. And then to convert back, you do this here. Now, the other common use for the modulo operator is to find out whether a number is even or odd. So if I take 99 and compute 99 mod 2, then that's 1, because 98 is even, and then you have a remainder of 1. And then if you do 100 mod 2, that's 0. So it's a general rule that if a number mod 2 is 1, then the number is odd. When mod 2 is 0, then the number is even. And that's often useful to know. All right, powers and roots. So there's a square root method to compute roots. So if I say math.square root of 100, then I get 10. If I say math.square root of 2, then I get 1.14. If I say math.square root of -1, then the keyboard melts into a puddle of plastic. Don't try it. Then you get a strange value called not a number. All right. To compute powers, there's no operator for raising to the power like this. You use a function. So you use math.pow. And so if I wanted to compute 10 to the 100, then it'll do that. Here, of course, I can use negative numbers. -1 raised to the 100 is 1.
So the math now,
Yeah?
or when I was trying to do the homework,
Yeah?
so we needed to use the square root the way in a fraction. But since I didn't use math not square root, they use math out, I use a fraction. But let's say cube root.
Yes?
So I use 1 divided by 3.
Okay. Oh, I see. So let's take the cube root of 1,000. So you did like this?
Yeah, but in the beginning I was having issues because it kept, for some reason I know that,
Whoa, 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 whoa. This is totally wrong.
That's not the key root, that's the
Yeah.
square root.
so what I did is that I had to use 1.0 divided
Yes.
by 3.0.
Okay. So first of all, notice that what's the cube root of 1,000? 10, right? 10 times 10 times 10 is 1,000. So why does it say 1? That can't be a round-off error. Round-off errors would be small. This is a big error, right? So the issue here is that, so what he observed is if you put a .0 here, then you'll get almost the right answer. This now is a round-off error, right? This is a round-off error for 10. But why did the first one not work? Yeah, when you look at this thing carefully, this is exactly what I was talking about a few minutes ago. On both sides of the slash, you have an integer. And so it computes an integer division. And 1 integer divided by 3 is 0, with a remainder of 1 that's discarded. And so that is just that common error that in a situation like this, one easily forgets that.
Where should we put the decimals just to be safe? I mean, on every number or just,
With slash, you just need to be mindful that at least one of them needs to.
so it's just in the division operation?
Yes, it's only the division operator where it's totally critical that you do this right. With multiplication, you'll get the correct answer either way, and generally you want to keep things as integers if you can. But with division, you definitely have to pay close attention to this. And so why did I put it at the over here and not over here? I mean, I could have also said right, that would have also worked. Well, the reason was that I had my cursor key at the end, and it was faster to hit the back arrow key only twice. Right, so if I have the cursor key here, then it's easier to put it. It absolutely doesn't make any difference where you put it. You can put it in both. You know, some people do this. They say better safe than sorry, and put it in both places. Come on.
What if you put a decimal point, 0?
You can do that too. And some people say, you know, that is economical because, you know, you're not contributing to the global pixel shortage. Some people think this is horrible, and so I don't really personally care that much which way you do it. Some people have strong feelings about it. All right. So ever so often you have to compute x squared, and if the variable name is short, you should definitely want to say x times x. You could say math.pow of x comma 2, but it's actually slower to compute it that way, a little bit slower, and it also is harder to read. If on the other hand you have a very long variable name, then the math.pow might be easier to read. But typically people will write x times x in this case. So we have square root. Yeah, here's, you see what I've been talking about before. So you have a mathematical expression that's nice and easy to read. And then in Java or in any common programming language, it gets spread out in this somewhat ugly way, and it takes more effort to see what it really means. But that's just the way it is. Okay, there's a whole bunch of other functions. We're going to be using sine and cosine for, or you may have already used it for the homework, right? Once in a while, one might use log. Min and max are very useful. In particular, it often happens that you want to cut something off at 0. You don't want it to be negative. So let's say you have a bug that keeps crawling to the left, and you have a rule that says the bug should never have a negative x coordinate. Then you could say, so if we have a position value, then you could say position equals max of position -1 and 0. And by doing that, you're guaranteed that it'll never get negative. Hang on. So I just want to demonstrate this here. So now position reached 0. And then the next step, position -1 was -1, but 0 is bigger than -1, so it stayed at 0. I'm sorry, say what?
Oh, I was just saying, like, is there a not equals?
Well, there's a not equals, but we're not, that's to compare two numbers. It's not an operator that changes a number. So you would use math min, math max whenever you want to cut something off at some lower or some upper bound. And it's a little bit confusing. Notice that I wanted to cut it off at the lower bound 0, and then you use math max. You want, this thing is the one that's in danger of being negative, and in that case you say if 0 is in fact larger than this negative value, use the 0. And I think this might occur in the exam. All right, casting, sometimes it happens that you have a number that's in a floating point number and you want it to become an integer, and the notation for that is somewhat archaic. You take the value that you want, and then before that you write in parentheses the desired type, which usually is int, and that will cut off the fractional part. So it'll turn this thing into an integer by discarding the fractional part.
Does it round it or does
It just cuts it off. So let's try it out. If I take int of 19.9999999, it takes the fractional part and just cuts it completely off. Now what happened?
Why didn't it work?
Because you went beyond that.
Too small?
What happened is that when I typed this thing here, I had more digits than actually used in a double. And so when the compiler read this, it said, well, I don't have that many digits, so I'm going to have to round it. And that rounding happened to push it over the edge to 20. And so it was 20 already in the storage, and then the cast gave you 20. So what that shows is that removing the fractional part is very rarely a useful operation, because it's so fragile that when you're at the boundary from one number to the next. So generally, you don't want to use it. The more useful operation is round. And so if I compute math.round of just even 19.9, then that gives 20. Or even 19.51, that gives 20. It rounds to the nearest integer. And that's usually what you want. Unfortunately, just to inflict some pain, the result is a long. And the reason for that is that it could happen that you have a pretty large number. So let's take 1.9 times 10 to the 30, math.round. That was probably, was that an overflow? That was probably an overflow. Yes, that was an overflow. So, so this one was too long to even fit into a long, but some numbers are long enough that you couldn't put them into int but into a long, and for that reason math.round returns a long, and that's almost never what you want, and whoever made these slides, which wasn't me, didn't put what you do want. You want to use int rounded equals int of math.round. So that combination of math.round and int is fairly common when you need to convert a floating point number to the closest integer. All right, and all right, just to show that you can do arithmetic, humor me with this one here. No. Does anyone know how to clear this thing? Control. Brilliant, okay. So n is 10, n plus plus. N is n mod 10. N minus minus. N minus minus. And n is minus 1. So correct answer is minus 1. Did everyone get this? Yes, so most people did. All right. So it's a good idea to be able to do this in your head, of course. So 10, 11. Now we take the remainder, that's 1, 0, minus 1. All right. All right. One of these rounding questions. Yeah, let's see. So if price is 1975, what's math dot round of price? It would be 20. And so when I take the integer of that, then that would also be 20. I guess that's not what's meant with to get the dollars. So let's look at the second alternative. If price is 1975, then the integer portion of that drops the fractional part, so it would get 19. That looks good. Let's see if there's a better answer. Price divided by 100 is what? I mean, that's not going to work, right? This would be 0.1975. And anyway, you can't assign a fractional number to an integer. So this one here would be a syntax error. So this can't be right. What about the last one? So I'm taking the price. So this would be 19. I multiply by 100. That would be 1900. I divide by 100. That's again 19. So it gives me the right answer. But it doesn't seem like the best way of doing it, right? There's no particular reason to multiply and divide. But it's not wrong. So if someone answered that, we can't fault them for it. So let's see what people did answer. All right, so this doesn't seem to be troublesome for most people. All right, so that brings me to the end of the lecture, so I guess I simply will have to answer more questions. Does anyone have questions? Or should I just go to Piazza? All right, so I'll go through a couple of Piazza questions, but if you want me to answer something else, just put them on here.
Are there any other math classes in Java other than the math one?
That's the only one you're going to be needing now.
I have one question
Yeah.
regarding a random number.
Yes?
It's only limited to 0 to 1.
Yes?
Is there a way to use it without using a loop or any ifs?
Say again?
Is there a way to create a random number from 0 to 1 without having to use?
Oh, okay. So his question was, and that's a good question, and it actually happens in one of the labs. How do you make a random number between, well, we know how to make a random number between 0 and 1. You call math.random.
Oh, it's always from 0 to 1.
It's always from 0 to 1, but now I'm going to ask the question that I thought you were going to ask. What if I want to have one that goes from 0 to 10? So then you would just multiply by 10. And now you get one that's random between 0 and 10. What if you wanted random between 5 and 10? Oh, that's an interesting question. So he says I could use the max function. So he says math.max of 5. And that's not false, but it does have the problem that the probability distribution is really bad, right? That half the time the answer is going to be 5. What was that? So I think what I heard someone say is to add 5, and that is in fact a better idea. So let's try that. So if you add 5, then it's always going to be bigger than 5, but sometimes it's going to be bigger than 10.
If you divide it by 2 and add 5, then...
Or maybe more simply, if I just multiply it by 5 here, right? Then, so you should think of this thing here as the length of the interval that you have. The interval from 5 to 10 has length 5, and this one here is the starting point of the interval. So with this, you can make fractional random numbers of any length.
So you could be like the interval like 5.25, so 5.
If you wanted to have a fractional number in that interval, so if you needed to have numbers between 5 and 5.25, then you would do it like this. And now you would get the numbers in this specific interval. All right, moving on. So here someone wants to know something about colors. And said someone used Belgian yellow as 255, 233, 54. And now he's wondering if the grader would take points off because the grader expected just color.yellow. Or maybe the grader actually wanted Belgian yellow. But the good news is that the grader isn't going to care. All that happens with these kinds of problems, the NetBrat takes a snapshot of what happens on your screen, there's no scientific way for anyone to know whether it's right or not. The grader glances at it, says, oh, that seems to look fine, and moves on to the next of 156 assignments. So if your flags are, at a different position, as long as they're visible, if the colors, are reasonably like the colors that one expects, everything will be fine. You could try to experiment and see what the grader is willing to take. What if you maybe make it pink instead of yellow? Would the grader notice? I have no idea. But so it doesn't exactly matter. It's nice, of course, to be precise about it. So by all means, go for it and do it this way. Notice also what this person here did very nicely is that they used uppercase letters here for these colors because they are kind of constants, right? You should think that this color, it's a weird color, and
That's why red and yellow and all those are caps.
that's right. Yes, because they're constants. They're just not constant numbers. They're constant objects. All right. Someone wanted to know. Sorry, he did the draft wrong. He gets 3 different lines coming diagonally from the top left corner out of the box towards the center. Oh, this is the one with the bug. Yes, and so let me explain the question here. Eventually, what we want to achieve is that bug, that one can see its trace nicely, that it looks like when it traces out a pentagon by turning like this, that it looks like this. But right now, we're not going to see that yet because it traces it in individual pixels, and so it only travels a few pixels, and that's why you see this little piece of junk here. That's normal. So when you get that in the draft, that's perfectly acceptable. So for the final, you're going to blow up the scale so that it looks nicer. And then the tester is going to be different for the final. You can have a look at it, and it's not going to do that line. So right now for the draft, it is totally simple. You just draw the line.
I think his issue is that there's 3 lines that's coming from everything from the origin. Basically, the error of his code is that his initial point, his previous point, is not being stored.
Oh, that may be. Oh, I see. So what this fellow may have done is that it looked like this. That would be bad. Yes, that would be wrong. So that means that this student would have only drawn the line between the origin and the current location, and not between the previous location and the current location. How the heck does one know the previous location? Because if you remember, the code says x equals x plus dx. So once you know the new location, the old location is gone. You could make a variable to store it, or for that matter, you could just compute the old one as x minus dx. Right? So either way, you can do it, but most people will use the variable. Should that variable be a local variable or an instance variable? Local, because you only use it in this method. You don't want to, actually I should put that in the rubric. You don't want to pollute your, your object with instance variables that are not needed beyond a single method. Let's see with other questions.
If you make a local variable public inside of the method,
You cannot make a local variable public. No. So here someone said, how come I didn't get any outputs? And this is a good question. When pasting this kind of stuff into BlueJ. So the way BlueJ works is as follows, that when you type an expression, something like 3 plus 4, then it evaluates it. When you type a statement, then because it's a whole statement, it doesn't have a value, and BlueJ doesn't show a value. So if I type an expression like Fred without a semicolon, you get to see the value. If I type Fred minus minus with a semicolon, that's a statement. It has no value, and no value is displayed. So it wants to show you the difference between an expression, something that has a value, versus a statement, something that has some kind of an effect.
So the expression, or the expression is going to give you a return statement. That's the
I couldn't use a return in here. If I tried to do return 4, then it would say I'm not really inside a method. I'm just in the code pad, and so there's nothing you can return from here. The message is a little bit confusing here. Apparently it considers the code pad as having a return type void. So that means if you wanted to have a sequence of steps like this one here, okay, I don't know how to fix this. Whatever. Okay, I'm not going to type the whole thing in. Well, what you want to do in this case, you want to type n. Now, it doesn't know what n is because it somehow picked up a bad character. So the point, though, is that if you wanted to see what the value is, you type n. I'll do it for a simpler example. So int n is 10, n plus plus, and now I just type n, and there you get it. You can also type system out print on n, and then it prints it on this display, but there's really no value in doing that in the code pad.
So when you just do this math over arithmetic on there, it's not affecting your code in any way.
No, so this is just a scratch pad. This is just to do quick and dirty calculations.
But yeah, if you were doing this on a regular,
Well, if you did it inside here, then you would write code which doesn't get executed until you actually make an object or call public static void main. So the advantage of the code pad is to give you instant feedback. The disadvantage is it's not part of your program. It's just something for a quick computation. But it is just totally useful when you want to run some quick experiment. Like, we've seen this before when you just wanted to know what does to lowercase do. And you just try it out. And so for these experiments, the code pad is hard to beat. There's no equivalent of that, by the way, in NetBeans. So this is a genuine advantage of BlueJ. All right, well, I guess we're going to call it quits here, so I'll see you one more time on Wednesday.